Now, we are going to take up one more problem on the overhanging beam. The problem reads as, draw the problem number 27. Draw the BMD and SFD for the beam shown in figure. Mark the salient values on the diagram. So here we have the reactions at the point A and B, which is at a distance of 6 meters, which is simply supported at two ends, and overhangs only at the point B by 1 meter of 60 kilonewton. And at the point D, you have a counterclockwise couple of 120 kilonewton meter, and at the point E, you have a 60 kilonewton acting downwards. Now, once you need to find out the reactions to the support. To find out the reactions to the support, so we have RBV into 6 will be equal to 60 into 7, then plus 60 into 4. Since you have the counterclockwise couple, so it is negative. So clockwise is positive. So that is on the right hand side, if you are considering, it is in the clockwise is positive. But now we want to write the this couple on the right hand side. So you need to consider that as the negative, minus 120. Or in other words, we can do like this also, that is RBV into 6 plus 120 will be equal to 60 into 4 and plus 60 into 7. So if you do like that, then clockwise couple will be equal to counterclockwise couple. So when you take it to the right hand side, that is plus 120 will going to become minus 120. Therefore, you will going to get the same equation. RBV into 6 will be equal to 60 into 7 plus 60 into 4 minus 120. So on simplification, you will going to get RBV as 90 kilonewton. And then also we know the sum of the vertical reaction acting upwards will be equal to sum of the vertical reaction acting downwards. So RAV plus 90 will be equal to 60 plus 60. Therefore, RAV will be equal to 120 minus 90 will be equal to 30 kilonewton, which is acting upwards. Now we are going to consider the shear force diagram. When you are considering the shear force diagram, SF at A will be equal to, considering the section to the left hand side acting upwards is positive. So SF at A will be equal to 30 kilonewton. So as we see between A and D, as the couple is not considered, so it remains constant at plus 30 kilonewton. Between D and E also, it remains constant at 30 kilonewton. Therefore, between A and E, it remains constant for plus 30 kilonewton. So then what happens? SF at E will be equal to plus 30 minus 60. So it becomes minus 30 kilonewton at the point E. SF will be acting. So SF it will going to reduce, drops from plus 30 to minus 30 kilonewton due to the point load at E. Between E and B, SF remains constant at minus 30 kilonewton. SF at B, as the load is acting upwards, so minus 30 plus 90 will be equal to plus 60 kilonewton. So between B and C, it remains constant at plus 60 kilonewton, and SF at C will be equal to plus 60 kilonewton. So this is how you will be able to analyze the shear force diagram for individual. So if you can see here, SF at A is 30 kilonewton. Between A and E, it remains constant at 30. SF at E will becomes minus 30 kilonewton. Between E and B, it is minus 30. SF at B, because due to the positive, because due to 90, so plus 90 kilonewton, it becomes positive. Between B and C, it remains constant at 60 kilonewton, and SF at C will be equal to 60 kilonewton. Now we are going to consider the bending moment diagram. So when you are considering the bending moment diagram, bending moment at the point A is 0, and bending moment at the point D, as it sags, so then it becomes positive. So when it is acting upward, so it becomes sagging, so naturally it becomes positive. So it will going to be plus 30 into 2 will going to become 30 into 2 will going to be 30 into 2 will going to become 60 kilonewton meter just on the left hand side of D. And as due to the couple effect you have in the counterclockwise direction, so this acts as in the upward direction, so it becomes clockwise, it is positive here. So since you have a counterclockwise couple, it becomes minus 120. So BM at D will be equal to minus 60 kilonewton. So that means BM at D, it drops from 60 kilonewton meter to the minus 60 kilonewton meter. Then at the point E, bending moment at the point E will be equal to plus 30 into 4 minus 120 will be equal to 0. So that is 120 minus 120 will be equal to 0. BM at B will be equal to plus 30 into 6 minus 120 minus 60 into 2 will be equal to minus 60 kilonewton meter. And similarly at BM at B or BM at C will be equal to plus 30 into 7 minus 120 minus 60 into 3 plus 90 into 1 will be equal to 0. So this is how you will be able to get the bending moment diagram. You can see here bending moment at the point A is 0, bending moment at the point D just on the left hand side, which is 30 into 2, which will going to become 60. So plus 60 kilonewton meter. So because due to the counterclockwise couple, it will drops from plus 60 kilonewton meter to the minus 60 kilonewton meter. You can see here sudden drop due to counterclockwise couple at left. Then similarly BM at the point E is 0, then it becomes linear again. BM at the point B will be equal to minus 60 kilonewton meter and BM at point C will be equal to 0. So this is how you can be able to analyze the bending moment diagram. So 60 and then it changes suddenly from minus 60 kilonewton due to the counterclockwise couple at the left, and the point of contraflexure is at the point D and here. So that is how the point of contraflexure we can see, which is at the point D, and we know the bending moment changing its sign from positive to negative at the point D, and we need not have to find the distance because the bending moment changing its sign from the positive to the negative just about 2 meters from the support A. So therefore you need not have to find the point of contraflexure distance because the distance is exactly at the point of 2 meters from A. So this is how you will be able to analyze the bending moment diagram and also the shear force diagram. Thank you.